Hi, and welcome to Gin with Gwynne. I'm Oliver Gwynne, and this is where we talk about marketing, data, and philosophy. This week, I have got for you three unconnected stories, all from NASA. The first one is a bit of an urban legend. You probably heard that in 1960, the space race is on, there's a Cold War, there is a race to the moon between the Soviet Union and the Americans. And NASA needs a way for the astronauts to ride in space, but of course, there's no gravity. And so they spend millions of dollars, taxpayers' dollars, to invent the space pen, a pen that can work without gravity. Meanwhile, the Soviet Union hands their cosmonauts a pencil. It's an old joke that you've probably heard a few times, and it has a great lesson that is often forgotten in today's complex and technical world, which is when you are thinking of a solution to a problem, think about the most common solution. What's going to get you an answer today? What's the easiest way to come to some solution? Too often we overcomplicate things, or we use too many sources of data or information to come to a more robust answer when the simple answer is right there in front of us. Now, in this particular case, I have heard it said that NASA did it on purpose. They could have used pencils, but they wanted an engineering challenge, and it was worth it for them to find a way to solve this particular challenge, which also affected other systems. But that is not true. In fact, the whole story is actually a bit of a myth. So let's go back to 1959. The Apollo mission is going off, and actually, NASA used pencils for the astronauts. And they spent a whopping $128.89 on one mechanical pencil, and they ordered 400 of them, which is an insane amount of money. Clearly, their supplier saw the word NASA and added a zero to the bill. And this got out in the public somehow, and there was an outcry about how much money are you spending on this? And so they decided they needed to go a different route. They also had a few concerns because if you've ever used a mechanical pencil, it's those ones where you click on a little button and a little bit of graphite comes on at the end. They're very easily breakable. The graphite often will snap off, and graphite, if you don't know, is a flammable material. So they were very worried that a small amount of graphite would get into the materials and set on fire. Now, at the same time, there was a separate company called Fisher who supposedly spent $1 million, which is where this huge sum of money comes from, to develop a pen that would work in very hot conditions, in very cold conditions, and without gravity. These pens use pressurized nitrogen to push the ink down into the ball bearing. And in fact, both the Soviets and the Americans ordered these space pens, which were then sold at a retail value of something like $650. So, while the lesson here about finding a simple solution to a complicated problem is a good one, the story is not really true. Let's fast forward in time to 1999. The Mars Climate Orbiter, a 638-kilometer robot space probe built at a cost of $125 million, burnt up and broken to pieces in the Martian atmosphere. Why? All because of a failure to recognize and convert between metric systems. One piece of ground software supplied by the spacecraft builder was producing results in US customary system developed from English units pound force seconds. But the trajectory calculation software supplied by NASA was expecting the results in Newton seconds. And the wrong calculation brought it too close to the planet, and it was destroyed in the atmosphere. So that's 125 million loss and a big reputation damage that could have been easily mitigated simply by having a standard data dictionary, a standard metric definition. This goes to show the importance and the huge sort of fault that comes from not getting your metrics aligned, where one person in your business is talking about a lead. Are they talking about the same thing as the other person? When somebody mentions profit, are they talking about the same figure as somebody else? If you don't standardize that across businesses, then the repercussions can be huge. And it's very difficult because the only way of doing that is to get the information out of stakeholders' heads, which is a little bit painful to sit with somebody and go, okay, I know what EBITDA is, but how do we calculate EBITDA? I know what a lead is, but how do we classify a lead? It takes time, and then often the results only live on a piece of paper, which then has to be referenced to make sure that we're all talking about the same thing. But this is an absolutely crucial thing that can stop you from wasting time and calculating the wrong thing later on, as in the case with NASA. Last but not least, a personal story for you about NASA. So when I was young, I was very lucky that I was able to go to space camp, an experience that I will never forget. And as part of space camp, one of the sort of things that you get to do is pilot a real Mars rover, a decommissioned Mars rover, a little robot type of thing, but one that was actually on Mars and had come back. And I always remember that we were given this puzzle, which was that the new Mars rover that they were sending up at the time would travel twice as far, it would send back twice as much information, and it would go last twice as long its lifetime would be, maybe 2 years instead of 1 year. Could we figure out how had they achieved this? And so we were guessing, a new source of power, new circuitry, better technology, all this kind of stuff. But no, what NASA had done is they built it twice as big, which I think says a lot about America. But coming back to our first story is also, I guess, what's the most simple answer to a complicated problem? Yeah, they built it twice as big. And so we had this challenge where we're in teams against each other, where we had a fake Mars surface and we had the rover, and we had to get from one side of the rover to the other. And there's an 8-minute delay. So half of us were actually piloting the thing and the other half were giving instructions while looking at the surface. And when it was my go, there was a huge crater in the middle of this surface, a really big surface that everybody else had gone around. And I decided I would go straight over the top of this big big crater. And we managed to break the record for the fastest course at the time. And I will say, everybody who was on my team was in absolute dismay when I did this. They were looking at me like, oh my God, what are you doing? What if we get stuck? We're definitely going to lose. But my thought process was that this Mars rover, even if it was decommissioned, was millions of dollars of equipment. They would not put in there an obstacle that we could not get around or that would break the Mars rover. And so I determined that I must be able to just go straight over the top, straight through this big crater, and we'd get there faster. And I was right in this particular case. It's a good example of sort of strategic thinking and narrowing things down to their most simple elements. Often in business, when we're thinking about problems, there is a limitation in our minds. There is a way of things that has always been done. There is a complexity that we have associated over many years as to how we would solve a particular problem. But when you stop and think about them from a strategic point of view, when you take away all those sort of outside elements of risk, of personal bias, of danger, and think, well, what's the easiest way of me doing something? Quite often that is the best solution. And it's not easy to do, but often when we think about things at their base elements and the strategic way forward, it works. And so here were 3 unrelated stories, all from NASA. Our first being, when you have a problem, think about the most simple way about solving it with the pencils and the pens. Our second being, make sure when you are framing those problems that you have got a common language throughout your business, that you're using some sort of dictionary or reference to make sure that you are not misconverting different metrics, which might have a huge outcome. And third is, wherever possible, put aside your own bias, your own history, your own way of doing things, which might be cultural or historical, and think about, how can I get there in a perfect world? And maybe there's a route forward for you there. Thanks very much for listening, and I will see you again next week.